Afternoon, parents. Next week we will still be in multiplication models and strategies. So our I can statements, I can solve 2-digit by 1-digit using distributive. It's supposed to be distributive property, or partial products. So I'm going to lay out exactly how we do partial products. So for instance, if the kids have a problem that has 23 times 3, standard algorithm, the way that we were taught, is just to simply do 23 times 3. So we say step 1, circle the ones place and multiply. 3 times 3 is 9. Then you do step 1. Step 2 is to circle the tens place. 3 times 2 is 6. Okay. Some of the kids like this method. A lot of them, they don't really get comfortable with this method and towards the end of the school year once they have mastered their multiplication facts. Now in partial product boxes, and which is what we're really going to be focusing on, the kids break down 23 into expanded form. So as you can see, we're always going back to that place value unit from the very beginning. So they say 20 plus 3 times 3. So they say 20 times 3 is 60, and 3 times 3 is 9. Then you add together is 69. In base 10 blocks, they would do 3 groups of 23. So then we say 10, 20, 1, 2, 3, 10, 20, 1, 2, 3, 10, 20, 1, 2, 3. So I said this is a group of 23, this is a group, and this is a group. So that goes back to what we've learned last week or this past week of equal groups. So then I count 10, 20, 30, 40, 50, 60, which is really the same thing as our partial product boxes, and 3, 6, 9. So then they still see is 69. Now when we're teaching kids, that's the partial products. When we're teaching kids the distributive property in partial products, I like to use graphing paper. So for instance, if the kids had, say for instance, the kids had another 2 by 1, and I like to show them on graphing paper of 3 groups of, say they had 3 groups of 13. And as you can see, it correlates so well, and it really helps the kids to visualize it. So on graphing paper, when they see this model, they're going to say, oh, okay, well, when we want to distribute it, that's the rows, the 3 rows. And so we actually go and do this. So they see, I'm sorry, I'm trying to stop at 10. So when they just see that, I show them and I said this is where we can distribute it at. So that is 10, 20, 30, and 9. So they're showing that that's 3 times 3, and this is 10 times 3. And that essentially is distributive property. Let me give you another example of distributive property. The kids can even have where I say, okay, I want you to show me, I'm just trying to do something not as big, really quick. 4 times, let's do 4 times 5. 1, 2, 3, 4. So 4 rows and 5 columns. So I say, okay, show me 4 times 5. And so what we do is actually build it on distributive property. I say, okay, now this is essentially 4 times 5. Okay, so where can we distribute this to break it apart in 2 pieces if we need to simplify the equation of 4 times 5? So I say you could chop it horizontally here, you could chop it horizontally here, you could chop it here vertically. And I teach the kids there's so many different ways to distribute 4 times 5. So if they want to distribute it here, I'm going to take this away. 1, 2, 3, 4. That's 4 rows times 1, 2, 3, 4, 5 columns. How could you distribute it? You could distribute it here, here. And I said, let's come up with as many ways we can distribute 4 times 5. So we break this apart. Essentially, we're saying that's 4 times 2, and this is 4 times 3. Because 4 times 2 is 8, and 4 times 3 is 12. The product at 8 plus 12 is still 20. Because essentially, this is still 4 times 5, which is equal to 20. And that is distributive property, and that is will be our focus for next week. And this will definitely help us as soon as we get into area of the second semester. Thank you for your time.